readings. Let's say that I have these two charges Q1 and Q2. As was done in my previous video, the force between these two charges in a vacuum space in free space without air, using this Coulomb constant, which is by the way equal to 9 times 10 to the 9, the force is equal to this Coulomb constant times one charge times the second charge over the distance between the two charges, so how far they are from each other, which is known as R squared. So this is the formula, this constant times Q1 times Q2, which are the two charges magnitudes in columns, over the distance between the two charges squared. So this is the formula for the force between these two charges. But now I can use this formula in order to determine the electric field strength of one of the charges. So let's say I want to take this charge's electric field strength, and that will be denoted as E, that's electric field, and it will equal the force over the charge, all right? And the charge that I'm considering is the charge that is taken inside, that it actually has an effect on. Therefore, this is the other charge. So I'm looking at the electric field of that's created by this charge, and this test charge, this outside charge that I'm using for the derivation of the formula for the electric field strength of this charge is used, the Q2, right? So what I'm doing here is, basically I will now use the F formula in order to derive the electric field strength formula in terms of the charge and the Coulomb constant and the distance between them. So the electric field strength can be written as the force between the two charges can be written as I've already said, K times Q1 times Q2 over R squared. And then I divide by Q2, which is the other charge. It's not the charge of which this electric field strength I'm looking for, but it's the other charge, it's this one, all right? So now I can actually use cancelling technique in order to simplify this and get to the result. So Q2 will get cancelled as follows. So this is the most important step. And now if I write the final solution, what it says is basically that this is the charge whose electric field strength I'm looking for, times Coulomb constant over the distance to that other test charge squared. That will be the electric field strength formula. So it's derived as follows. It's very simple.